Hey guys, it's Miss Johnson and I'm here to bring you our second notes video for Unit 3. Today we're talking about adding and subtracting polynomials. So our learning target today is exactly that. I can add and subtract polynomials. So to add polynomials, pretty basic, we're all comfortable with it, we know what to do. Adding polynomials just means we're combining like terms. So we need to find those terms that have the same coefficient and put them together. We need to also make sure that we write our answer in standard form, which again from yesterday means that we are writing them in order of decreasing exponents. So let's do a couple practice questions. In number 1, I have that whole big long polynomial there. And again, writing these in standard form, this is going to be really similar to what we did yesterday. This is kind of a review. I start by looking for that largest exponent. The largest exponent I see is the third. So I have 2x to the third and 8x to the third. 2 plus 8 gives me 10. So 10x to the third. Then I notice that the next one would be the seconds. I have the 3, and I'm done with those. I mentioned yesterday how you could cross those out if that helps keep you organized. 3x squared minus, that's a subtraction, minus 5x squared. 3 minus 5 is negative 2, so negative 2x squared, done and done. Then I would look at the x terms, negative 7, positive 4. Negative 7 and positive 4 is negative 3x. And I would look at the constants. Positive 12, negative 5, 12 minus 5 is 7. So then I'm done with those. That's the standard form definition. It's naturally in standard form because I started with the largest exponent and decreased from there. If you would have just gone left to right, you might have had some rearranging to do, and that's fine. You can do that too. But I just like to look for the largest exponent first and go down from there. If I take a look at number 2, again, start with the largest exponent. The largest exponent is 7x to the third, and there's nothing else to put with it, so it's just 7x to the third. Then I have my squares. There's a 3 and a negative 2. 3 minus 2 is 1, so that's just plus 1x squared, or just x squared. Then I would have my x terms. There's a negative 7 and a negative 9. Negative 7 and negative 9 is negative 16x. And then I have the constants 9 and 11, which is 20. So that's just combining like terms. Now, what happens when we have two polynomials that are in parentheses with an addition sign between them? So we have a couple of methods to look at. One is to do them horizontally, meaning we line the terms up straight across and just go ahead and combine them like we did before. So all I would do in this one is kind of do what I've been doing. When I have this polynomial plus that polynomial, I don't need to worry about anything being multiplied to either one, because that's usually what we're looking for when we see parentheses like this, is there anything that needs to be distributed? But in this case, there isn't, so I would just go through, combine them like ones together. 4x squared and 2x squared is 6x squared. 3x and 2x is 5x. And negative 2 and 1 is negative 1. Okay, so that's just going through. Now, excuse me. Okay, so now we can also line them up vertically. And when we line them up vertically, we're going to put our like terms in columns. So notice that I have my x to the second and x to the second right underneath each other. One's right underneath the other. I have my x terms lined up in this column. I have my constants lined up in this column. And then it becomes adding just like it was way back in elementary school when we used to add things vertically and we would combine like place values. So in this case, negative 2 and 1 is negative 2, 3x and 2x is 5x, and 4x squared and 2x squared is 6x squared. Now notice, by the way, that as I've been combining all of these like terms, my powers haven't changed. We don't change powers when we combine like terms, we just add their coefficients together. So two methods that you can use there, and I'll show you a couple examples of each. Let's talk about number 5. In number 5, I have 3x squared minus 4x plus 8 and 2x minus 7x squared minus 5. I always try to circle what's in the middle because I want to remind myself if there needs to be anything distributed. In this case, there isn't. It's just addition. So let's do this one vertically. I'm going to line up my like terms in columns. So I have 3x squared and then negative 7x squared below it. Then I have minus 4x and plus 2x below it. Then I have plus 8 and minus 5 below it. Notice that in the second polynomial, the x and the x squared term were reversed from each other, or were in backwards order. So you have to make sure that you line up the ones that are common, even though they're in a different order from the first one. So now, when I add those together, 3 plus negative 7, or in other words, 3 minus 7, is just negative 4x squared. Negative 4x and 2x is negative 2x, and 8 and negative 5, or 8 minus 5, is 3. So that is my addition. So in the second one, 5x squared minus 3x plus 4 and 6x minus 3x squared minus 3. I'll just go ahead and do this one horizontally. So that just means I'm looking for what's in common. I notice that the squareds are my largest exponent. I'm going to start with that. 5 minus 3 is 2. I'm done with those. Then I need negative 3 and 6x. Negative 3 plus 6 is 3, so plus 3x. And I'm done with those. And 4 minus 3 is 1. And I'm done with those. No other terms. I'm done. Now, when we subtract polynomials, subtracting polynomials is a little bit different. We need to make sure that we distribute the negative to each term behind it. And then we just go back and combine like terms. So it's kind of like saying that each term behind it, the subtraction sign will be its opposite, okay? Each term behind the subtraction sign will be its opposite, and then the subtracting will become addition. So if I look at this little example down here, if I add this minus sign in between, that means that it gets distributed, which makes that 3x squared a negative, that x, negative x, a positive x, and that positive 5, a negative 5. And then I can go ahead and put my like terms together, and then I'm good. So let's just talk about that. Think of subtraction as distributing. And another way you can recognize that this is distribution is kind of like saying you have a negative 1 in front. So it's like you're multiplying everything behind it by negative 1. So when I do that, I have 4 times g to the third minus 5g. Then that subtraction becomes addition, and behind it I have negative 2g to the third minus 4g. Now I can just go ahead and combine my like terms. 4g to the third, negative 2g to the third, 4 minus 2 is 2. So 2g to the third. Negative 5 and negative 4, they're both g terms. So negative 5, negative 4 is negative 9g. Okay, so take that subtraction that's in the middle. That's kind of why I like to circle this sometimes, so that I recognize, oh yeah, that's subtraction, that's got to go in the middle. It's really easy to look at a question like this and just automatically think it's adding and put your like terms together, even though that's not what's happening. So next thing I would do here is I need to combine my like, or let's rewrite it. So I have 3n squared plus 13n to the third plus 5n. That one didn't change. The subtraction goes to what's behind it. So now this is adding negative 7n minus 4n to the third. So now I can combine my like terms. I have thirds here. 13 minus 4 gives me 9. So I have 9n to the third. Done with those. Then I have this n squared that's by itself, so plus 3n squared. Done with that. Then I have the n terms. 5 minus 7 is negative 2n. And there is my sum. Take a look at number 9. Still subtracting here, so I'm going to distribute that subtraction throughout. Now some of you may start to be able to just slash this into addition and make everything behind it its opposite. So rather than rewriting the whole thing, that's fine with me, but you need to make sure that you make everything behind it its opposite. So I made that addition, the 4 became a negative, the negative 9 became positive. And now I can go back and put those together. So I have negative 5y squared and, I'm sorry, 5y squared and negative 4y squared. 5 minus 4 is 1, so just y squared. Then I have a negative 3y that's by itself, and I have 8 plus 9, which is 17. And that is my like terms, or my sum. So then in number 10, again, if you want to go through and just make this addition, then that becomes subtraction, addition, subtraction. Then you can go back and combine your like terms. So I have a couple of weird things going on in this question. I have this 3x squared and negative 4x squared. That is simply a negative 1x squared, or just negative x squared. Then I have this weird xy term. That's something we don't see very often, where there's more than one variable in the term. It's still a term, and it still has a like term over here. This has an x and a y, this has an x and a y. They're raised to the same powers, so they are like terms. So the negative 8xy, negative 6xy is negative 14xy. Then I also have those y terms. Negative 5 and positive 2 now is negative 3. So negative 3y. So there is my answer. So let's talk about number 11, and then we will be all set for today. Number 11, the total number of public school teachers, T, consists of two groups, elementary and secondary. From 1992 to 2003, the number in thousands of secondary teachers and the total teachers could be modeled by the following equations, where n is the number of years since 1992. So here are my secondary teachers. Here are my total teachers. Okay. Now we want to find an equation that models the number of elementary teachers for this time period. So we want to know, what does E equal? Well, the elementary school teachers is going to equal whatever the total number of teachers is minus the secondary teachers. So I need to take the total, subtract the secondary. Once I do that, I've got the elementary. So that's what I'm going to plug in. I have E is equal to this expression for T. I'm going to make sure I put it in parentheses. That's really important. And then I'm going to subtract this expression for secondary. And again, make sure you put it in parentheses. We have to group it together because it was an expression that was all together to start with. So I have this expression minus that expression, and now I need to combine them. So I'm going to make this adding, make that subtracting, and subtracting. You might want your calculators out for this if you don't have them out already. So when I put those together, 58n minus 29n is 29n. And then 2,401 minus 949 is going to be positive 1,452. And then my label here is teachers, because that's what we're talking about, is how many teachers there are. That's the equation that will tell me the number of elementary school teachers. All right, so we are finished for today with our notes video. You need to do your practice assignment, so make sure you check your notes off and come get your practice assignment. And I will see you all later. Thanks.